Opportunities and challenges of domestic CAD in China. In the modern industrial system, computer-aided design CAD is not only a standard drafting tool for engineers, but also the underlying support for the digital transformation of the entire manufacturing industry. As the core of R&D design software, CAD directly defines the digital ecosystem of products, from concept to representation. For China, the development history of domestic CAD is not only a marathon of technological catch-up, but also a geopolitical game, a crucial battle to ensure industrial security and technological sovereignty. From early imitation and following to today's independent substitution in specific fields, Chinese domestic CAD brands have experienced decades of ups and downs and are now reaching a historical turning point from quantitative to qualitative change. Using the analogy of infant growth, they have moved beyond their first steps and entered a period of rapid growth. However, some common shortcomings still exist in high-end industrial applications, core 3D technologies, and the ecosystem. In the global industrial software market, CAD, computer-aided engineering, and CAM, computer-aided manufacturing, are collectively known as CACs, the soul of the manufacturing industry. For a long time, this field was monopolized by international giants such as Dassault Systems, Siemens, and Autodesk. However, with the dramatic changes in the global political and economic landscape, especially after the outbreak of the Russia-Ukraine war and the resulting technological blockades and sanctions, the independent and controllable nature of industrial software has risen from an academic topic to a national strategy. Under this grand narrative, the rise and fall of domestic CAD brands is not only related to the survival of enterprises, but also reflects China's arduous journey from a manufacturing giant to a manufacturing powerhouse. The past of China's domestic CAD industry is a story of 100 schools of thought contending to a struggle for survival in a wilderness. China's CAD technology started in sync with the world. In the 1980s, accompanied by the wave of reform and opening up and the initial budding of the national informatization strategy, 128 private and state-owned enterprises engaged in CAD research and development were established in China. During this period, domestic R&D efforts were mainly concentrated in research institutes and universities, with technological approaches primarily based on collaboration, imitation, and secondary development. At that time, computing technology was listed as a national emergency measure. The Chinese Academy of Sciences and other institutions began to establish specialized research institutions, attempting to seize the initiative and gain a competitive edge in this emerging field. Early domestic CAD developers were filled with idealistic, bookish fervor. They attempted to automate industrial drafting through algorithmic innovation within limited hardware resources. However, in the 1990s, international giants like AutoCAD, with their mature business models and superior user experience, penetrated the Chinese market. Coupled with weak copyright protection awareness at the time, rampant software piracy struck, and domestic CAD companies, lacking a commercial ecosystem, suffered a devastating blow. Within a mere decade, private enterprises were wiped out. By the mid-1990s, the commercialization of domestic CAD entered its darkest hour. Faced with the overwhelming dominance of foreign products, state-owned R&D forces also experienced a dramatic exodus. Of the once ubiquitous R&D institutions, only 16 national key laboratories for CAD remained, preserved as a spark of technological innovation. These laboratories, primarily reliant on large state-owned enterprises or top universities, maintained basic scientific research through government subsidies. The technological paths during this period mainly diverged into two branches. One was secondary development based on the AutoCAD platform to meet Chinese national standards. The other attempted to develop a completely independent geometry engine from the ground up. However, due to a lack of repeated refinement in real-world industrial scenarios, many research results often remained at the paper stage, failing to translate into market-approved physical products. This severe disconnect between technology and the market caused domestic CAD to suffer repeated defeats in direct competition with international brands. Entering the 21st century, the research and development of domestic CAD further shrank towards academia. Of the original 16 national key laboratories, only the Zhejiang University CAD and CG National Key Laboratory survived in near-death experience, barely maintaining weak research activities. This single-track academic transmission situation reflected the neglect of basic theoretical research in the domestic software industry at the time, as well as the lack of interest from the capital market in low-level toolchains with extremely long return cycles. Meanwhile, overseas returnees began to pay attention to the gaps in domestic industrial software. With the implementation of national-level policies for attracting overseas returnees, such as the Spring Breeze program, a group of researchers who had been exposed to advanced CAD, CAM technologies overseas began to return to China to start their own businesses. Our HiwayCAD 1.0 was born against this backdrop. In 2008, the project team returned to China to participate in the third Chunhui Cup Innovation and Entrepreneurship Competition for overseas Chinese students. Based on their advanced academic concepts, they won first prize. However, the initial entrepreneurial environment failed to provide sufficient hardware support for our team, these idealists. Although the entrepreneurial parks treated overseas student teams with great courtesy, the actual industrial support, long-term investment and financing support, and market access mechanisms for core design software were not yet well established. After visiting several parks, the HiwayCAD team found that although they were treated like royalty everywhere, the level of support was lacking. Ultimately, this caused the team to lose confidence in the entrepreneurial prospects, leading to the project's temporary suspension. Looking back at the setbacks of HiwayCAD 1.0, we can see that it represented the common predicament of a generation of returning technical personnel at that time. This setback was, to some extent, the price of their bookishness. Entrepreneurial teams often only considered the advancement of technology, ignoring the unique business and political environment of China. In China, the fate of high-end industrial software is inextricably linked to the government's performance and the country's strategic plans. Historical experience shows that without official endorsement, purely technological innovation is extremely difficult to shine in the resource-intensive heavy industrial software market, and is easily overshadowed. This Huzuyan-style business acumen is particularly evident in the CAD industry. Domestic CAD companies that survived and thrived often invested heavily in public relations, building government relationships, and securing national special funds before even developing their own technology. As industry insiders have pointed out, once the fate of CAD is tied to the performance of government officials, the level of support undergoes a qualitative change. This profound insight into the industry environment, while somewhat limited by its time, became a crucial strategy for later domestic software companies to survive in the competitive landscape. After more than 2 decades of ups and downs, the Chinese CAD market has developed a clearly stratified competitive landscape. While international giants still dominate the high-end market, domestic manufacturers have established their own foundation through differentiated competition and the support of domestic substitution policies. ZW3D, self-developed 3D geometry kernel. Starsoft, independent 2D kernel, 3D kernel in cooperation with Siemens, 2D kernel accounting for over 90%, mobile app King with tens of millions of users. Huashan Software, self-developed 3D modeling engine, focusing on cloud-based modeling and multiphysics simulation. Digital China, integrated 2D, 3D development, emphasizing deep integration of product lines and production. Currently, ZW3D has the highest market share among domestic manufacturers. In 2022, its share in the Chinese design and R&D CAD market reached 9.6%, ranking 4th globally, only behind Dassault Systems, Siemens, and Autodesk. Starsoft, on the other hand, performed strongly in the 2D field. Especially in mobile and collaborative applications, it has accumulated a massive user base through Gestark Viewer, further consolidating its brand influence. A major indicator of the domestic CAD industry is that 2D graphics technology is basically mature, capable of replacing AutoCAD on a large scale. However, 3D graphics technology still has a long way to go and remains far behind international advanced levels. In fact, in the AI information age, 2D drawings are technically no longer very useful, because 2D drawings can be automatically generated using 3D drawings. The current version of HiwayCAD's cabinet series is a typical example. Editing is entirely done on 3D models. Once completed, issuing a 2D construction drawing command automatically generates a 2D construction drawing based on international standard drawings. The core of 3D CAD lies in its geometric modeling engine and geometric constraint solver. Currently, Dassault Systems and Siemens monopolize the global high-end market. Domestic software like ZW3D, while attempting to develop its own kernel, still lags significantly behind foreign products in stability and efficiency when handling ultra-large-scale assemblies such as large aircraft and aircraft carriers and complex non-uniform surfaces. Leading international vendors have long achieved deep integration of CAD, C, and CAM. This means that designers can perform stress analysis and machining simulations simultaneously with model completion. In contrast, most domestic software is still in the stage of single-point breakthroughs. Although ZW3D accelerated its efforts to address its shortcomings in fluid simulation through the acquisition of CAM, building a complete multiphysics simulation solution covering structure, electromagnetics, and fluid dynamics still requires time. While companies like HiwayCAD Software have launched cloud-based products such as CAD, attempting to achieve a leapfrog development in cloud modeling, concerns about data security in the domestic manufacturing industry and its reliance on traditional workflows have resulted in the adoption rate of CAD remaining far below expectations. The 2022 Russia-Ukraine conflict was an undeniable turning point in the history of China's industrial software development. At that time, Autodesk announced the cessation of all operations in Russia and the shutdown of its local AutoCAD service. This sudden event made industries around the world acutely aware that the dangers of relying on foreign closed-source software are no less than those of relying on other countries' energy or food supplies. Once geopolitical relations break down, a country's industrial design system could be severely hampered, potentially paralyzing its entire industrial production. In this context, Chinese-made CAD software gained a rare opportunity for development. The national government issued directives requiring key industries and critical positions to gradually switch to domestic brands. Although initially some users, accustomed to foreign products, simply shelved the domestically purchased software and continued to use foreign products in practice, the consensus that cultivating domestic products is a long-term strategy has undeniably formed. Government policy support not only provided domestic manufacturers with much-needed cash flow but, more importantly, brought massive amounts of real user data, the only path for industrial software evolution. However, independent engines are a double-edged sword. The advantage lies in reducing dependence on external supplies. The disadvantages are that quality, reputation, and overall level are inferior to imported brands. Most sensitively, in the AI era, an independent engine that remains isolated and out of step with the mainstream cannot truly be called AI. For example, AI can directly create drawings for well-known open-source CAD engine brands, but it is ineffective for smaller, closed or semi-closed CAD brands. In addition, as the old business adage goes, never make something yourself if you can buy it with money. Regarding the common shortcomings of domestically developed CAD software, the industry generally agrees on the following. 1. Low self-development rate of core geometric modeling engines. This is the most critical bottleneck for domestic CAD software. 2. Lack of geometric constraint solvers. If the engine is the heart, the constraint solver is the brain. 3. Poor ecosystem and plugins. CAD software is not just a drawing tool, it is also an industrial foundation. 4. Insufficient integration of C simulation and CAM. Modern industrial design emphasizes the integration of CAD, C, CAM. 5. Lack of industry experience and knowledge. The strength of CAD software lies not only in its code but also in its understanding of industry standards. Although these shortcomings are obvious, domestic CAD software can demonstrate a late mover advantage in cloud-native architectures, such as CAD exploration based on browser, Blazor technology, which is precisely HiwayCAD's approach, and targeted industry customization. For developers, achieving efficient geometric calculations within modern front-end frameworks like WebGL, Babylon.js, which is also HiwayCAD's approach, might be a way to leapfrog the competition in the future. Currently, all domestic CAD brands in China use their own proprietary engines. This absolute approach is definitely problematic. In fact, whether the engine is imported or developed in-house, both are extremes, opportunistic leanings, and ultimately doomed to failure. The best solution would be to prioritize using internationally renowned engines while simultaneously reverse engineering a copy as a backup. If the preferred brand fails, the backup can be immediately used as a replacement. This article emphasizes that the concept of 2D model creation is obsolete and history. A true leader in CAD should focus all its efforts on 3D models. 2D models should be automatically generated from 3D models. For large, complex 2D drawings, they should be placed in a grid. Each grid is considered a unit. All units are drawn independently and then assembled like a jigsaw puzzle. This approach fully utilizes the capabilities of AI. The key is to break down large, complex graphics into combinations of smaller, simpler graphics. Isn't that wonderful? As a former first prize winner of the Chenhui Cup, the HiwayCAD team possesses a solid foundation in Western cultural knowledge on a technical level. Although they encountered setbacks during their early entrepreneurial phase in China, the team continued to upgrade and innovate the system, always staying at the forefront of technology. HiwayCAD once had the opportunity to establish a CAD research lab in Shenzhen, but this fell through due to a chance event involving the transfer of a contact official. If HiwayCAD could restart its collaboration with national-level research institutions, the opportunities lie primarily in the following areas. Subsidies from national and local governments for the development of bottleneck technologies are now far greater than they were a decade ago. In the high-end manufacturing sector, clients highly value the technological origins and continuous R&D capabilities of software. HiwayCAD's R&D team, situated within a Western cultural context, can easily identify, accept, and apply new technologies and concepts. Developing specialized modules for specific fields such as domestically produced large aircraft and domestically produced chip design. These fields have a small user base but extremely high demands for customized CAD solutions and are not stingy with prices. Utilizing cloud technology to provide private CAD collaboration clouds for defense and military units requiring high levels of security. Currently, the education sector accounts for 36% of the CAD market. HiwayCAD can leverage its academic connections to cultivate a new generation of users of domestically produced software through university-industry collaboration. According to industry analysis, the Chinese CAD market will maintain rapid growth over the next 5 years, driven by the robust manufacturing sector, strong demand for existing IT infrastructure, and government crackdowns on piracy. The CAD market is expected to reach 22 billion yuan by 2026. This data illustrates that while the 2D market remains the primary source of cash flow, the 3D market represents the future's vast potential. One of the three major directions in the evolution of CAD technology is the shift from plotter to generator, an AI-driven design revolution. The CAD of the future will no longer be a pen in the engineer's hand, but an auxiliary brain. By introducing generative design, software can automatically calculate the optimal structural topology based on parameters such as weight, materials, and loads. This is the forefront where domestic software can compete on a level playing field with international giants. With the widespread adoption of 5G and edge computing, CAD will completely break free from its dependence on expensive graphics workstations. As demonstrated by Huashan Software's CrownCAD, designers only need a browser to handle complex models. This architecture not only reduces costs but, more importantly, achieves a data closed loop encompassing design, simulation, process, and manufacturing. The leading companies of the future will inevitably be service providers capable of offering end-to-end CAD computer-aided system solutions. ZW3D's acquisition of the UK-based CAM signifies that domestic manufacturers have begun to establish a presence in the fluid simulation field. In the future, CAD will no longer be isolated. It will be deeply integrated with digital twins and smart factories. Chinese domestic CAD brands are experiencing a historic golden decade. From the chaotic period of numerous competing companies to the current concentration of leading players, the industry is maturing. Although it still faces challenges from decades of Western technological accumulation in key areas such as 3D kernels, the catalytic effect of geopolitics has fundamentally changed the rules of market competition.